Hello. So in this section we are continuing our work on binomial expansion, and last time we looked at how we expanded any binomial x plus a to the power of n for some integer n, right? At some power of n, we expanded it using the binomial theorem. So it looked something a bit like this, right? So we said it was n choose 0 first. Then that would be x to the 0, and then that would be a to the power of n. So the powers match to get us n, which is the power there. So that's our first term. Obviously, that's the first term of x, which has a power of 0. Then we said n choose 1 for the next term, and then there'd be a power of 1 for the x, and then a would be the power of n minus 1. Then we did n choose 2, and then that'd be x to the power 2 then, and an a to the power of n minus 2, and then we continued until we got to the last term, which was n choose n. Then x would have a power of n, and a would have a power of 0. Okay, and so hopefully, and that's the binomial theorem, or the binomial expansion, and hopefully you notice that the coefficient, this binomial coefficient we call it, this n choose 0, say, the value of r, so we obviously in general it's n choose r. The r, the value that we use, it corresponds to the term of x, right, the power. So n choose 0, then we have x to the 0, and so on. And so that's what we did, right? We did all that for all the terms, if necessary. And so then we can get our expansion. Okay. Now, what we're going to look at in this section then, so we should have a good idea of how to expand binomial brackets using this idea. What we're going to look at in this section is some more trickier examples with more complicated binomials. Okay, before we proceed then, I'm going to do some quick examples. What you're going to be what's going to be very useful to do in this section is we're going to be looking at picking out only particular terms. So not the full expansion, but only particular terms. So for example, if we had, say, x plus 1 to the power of 6, say I want to find the x squared term here, right? Not the whole expansion, but the x squared term, right? Wow, this expansion is going to just be all x's to power 6, right? So it's going to be x to the 0, which obviously be some constant. But anyway, x to the 0, add x to the 1, add x squared, and so on. Add x to the 6. Obviously, there's going to be some constants in front of them. But that's the idea, right? This bracket would expand to get some sort of polynomial in this way, right? Up to x to the power 6. But we only want the x squared term, and I don't want to do the full expansion because I only need one particular term. What we're going to do then is, using this sort of idea we just discussed above, well, the x squared term, well, our coefficient is going to be n choose 2, because then it's going to be the power of x squared, and then the other number, 1, in the bracket, then that's going to be a power of 4, right? And so there we are then. So then we can just put this in the calculator. Well, n would be 6, sorry. There we are. 6 choose 2. So 6 choose 2 would be 15. Then 15 times 1 to the 4th is 1. So we just get 15x squared. There we are. So that's the x squared term. 15x squared. It's cool. So you can see we quickly do that to find a particular term without doing the full expansion, and that will be important to save a lot of time as we look at other examples. Okay, let's have a look at this one. I have now 2x minus 1 to the power of 8. I want the x cubed term this time. So that's going to then be, well, 8 there, choose 3, because that's going to be the power of x. We want the term of x. Then it's going to be, well, it's not going to be x. It's not going to be x cubed because we have 2x. So it's going to be 2x all cubed. Then we're going to have the minus 1, the other number in the bracket, to the power of, well, it'd be 5, right? Because 3 and 5 gets me 8. So there we are then. We just put all that in the calculator. Well, 8 choose 3. that's going to be 56. Then 2 cubed, times that by 2 cubed, I get 448. Then minus 1 to the 5 is just minus 1, so that'd be minus 448 x cubed. And there we are. So that's the x cubed term there. Cool. Last example, before we look at proper examples. I have, let's say 4 take away a half x to the power of 7. I want the x to the 4 term. Okay. So x to the power 4, well again, it's going to be 7, choose 4, because that's the power of x we want. Then the power will be, well, not x to the 4, it's going to be this minus a half x to the 4. So all of that minus a half x will then be a power of 4. Then the other number, 4, there, would then be a power of 3. Okay, because then 4 add 3 gets me 7. Cool. So I put all that in the calculator. Well, 7 choose 4. It's going to be 35. 35 times minus a half to the power of 4. That's going to get me 35 over 16. Then times by 4 cubed, I get 140. So 140 x to the power of 4. So there we are then. So hopefully you start to see the idea how we can select certain terms and how we choose out, how we work out the coefficients and how we work out the overall term in that way by considering the power of x, right? The term of x. Okay, so that will allow us to solve certain questions quickly where we only need certain terms, meaning we don't need to do the full expansion. Okay, cool. Let's have a look at some examples. So first of all, it wants us to find a coefficient of x to the 4 of the expansion of 2 plus 3x to the power of 10. So very similar to what we just done, but they want the x to the 4 term, right? Only x to the 4, so not the full expansion. So that's going to be then, well, it's going to be firstly the coefficient is going to be 10, choose 4, because that's the term of x, the power of x we want. Then it's going to be not x to the 4, but 3x to the 4, because that's what we got in the bracket, or to the power 4. Then the other term, or the other number in the bracket 2, will then be a power of 6, right? And there we are. So put all that in the calculator. Well, 10 choose 4 is 210 times 3 to the 4 is 17,010. Then times by 2 to the 6, we get this massive number here, 1,088,640, and that'd be x to the 4. Well, there we are then. So the coefficient, the number in front of x to the 4, is this million, right? So the coefficient is this, right? 1,088,640. There we are. Cool. And if we did it, expanded it, you know, if we then expanded the full thing to kind of find the x to the 4 term, it'd be very long because it's a power of 10. And the numbers are quite big, as you can see here as well. So it's way more efficient when we can spot how to deduce certain terms in this way. Okay, part B then, find the coefficient of x cubed in the expansion 2 plus x, 3 minus 2x to the power of 7. Okay, so it's a bit tricky now because we have two different brackets. However, this one I can't do anything with. It's not raised to a power, it's simplified. But this is to the power of 7. So I think we can expand it using the binomial expansion and go from there. Okay. So 3 minus 2x to the power of 7. Well, actually, no, let's think about it in this case. Let's think about it. We don't want to expand all the terms, do we? Because, like I said, they're going to get quite a lot of terms. All I want is just one term, x cubed. But think about it. This whole bracket, 3 minus 2x to the 7, is then being multiplied by this. But as we've seen, 3 minus 2x to the 7, if we expand it, if we kind of imagine, it's going to be basically a constant well, that'd be like x to the 0, add x to the 1, add x squared, add dot dot dot, add x to the 7, right? That's what we're going to get, some polynomial degree 7. Obviously the coefficients will be there in every term, but we don't, the whole idea is we get a polynomial, right? Okay, but then this, if we were to expand it, we would get this sort of polynomial. That would all then be multiplied by 2 plus x. So then we would effectively have 2 plus x times by x to the 0 at x, well, x to the 0 I'm just going to call, let's say a, for some number a, right? Because x to the 0, remember, power of 0 is just 1. Actually, I'll just call it 1, actually. 1 plus xn plus x squared plus dot 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 plus x to the 7. Okay, that's effectively what I would get if I expanded it. Obviously, there's some missing coefficients, but that's not what I'm interested in at the moment. But then, well, this is kind of another expansion. I'm expanding this bracket with this bracket. The question wants me to get the term x cubed from this, right? Now think about it. How, if I was to expand these two brackets, how would I get the x cubed terms if I did the expansion? Think back to when we did expanding brackets right earlier on in the course. How we expand a bracket like this is the first term of the first bracket, say the 2 here, that multiplies by every single term in the other bracket, right? So 2 times 1, and then you get 2 times x squared, and then 2 dot dot dot, and 2 times x to the 7. So 2 is being multiplied by every x term. Now think about it. How would I get x to the x cubed from that? So I want an x cubed term. How would I get x cubed from that? Well, you'd have to have the x cubed term from here, right? So if I said, say, x cubed here, add dot dot dot, then x to the 7. Well, the only way I can multiply 2 by all the terms in this bracket, right? The only way I can get x cubed is to times it by the x cubed part, right? 2 times x cubed, well then there we are. So that'd be 2 times x cubed. However, that's the first term, the 2 in this left bracket. But then we would multiply the x here, the other term, by all the terms in this bracket as well, right? And so then you'd have x times 1, x times x times x squared, x times x cubed, and then all the way up to x times x to the 7. So then the x is being times by everything as well. Now, with the similar sort of logic, how am I going to get an x cubed term by multiplying x by all the terms? What term in particular do I need to consider? Well, hopefully you realise it'd be x squared here. So from all the terms in here, what term do I multiply by the x to get x cubed effectively? That's going to be the x squared term, because x times x squared will then get me x cubed. So x times x squared, right? If you said x cubed, well then x cubed times x would actually be x to the 4. So that's not an x cubed term overall. Okay, it's a bit tricky to get your head around at first, but hopefully you realise what we've done there. So that's what we'd do, right? So you'd first multiply the 2 by the x cubed term that of the expansion we did up here. Then for the x part, but then x would have to times by the x squared term, right? So effectively what we've got, if I get rid of it, is 2 times x cubed, and then x times x squared. That would give me the overall term for x cubed, okay, here. So that's the idea. Okay, hopefully you can see that. I'm basically looking for all the ways I can get x cubed while multiplying the bracket without multiplying it term by term explicitly, because that takes too long. What I'm trying to get at is trying to help you visualise how I'd get certain terms from the expansion rather than just doing the expansion itself, because it'd be very long. So hopefully you can see that, right? This is how we get x cubed, by multiplying those two terms in particular. But there we are. So that's the idea. However, like I said, this is not the actual expansion. I've just done a rough sketch. That's what it would look like, that polynomial. But there are coefficients involved. So I need to find the actual number now, well, the actual expansion, by doing the binomial expansion we did before. Now, as we discussed, we only need the x cubed and the x squared terms from this expansion. We don't need all 7 terms, or 8 terms actually, from x to the 0 to x to the 7. I'm only interested in, if I was to do this expansion as we saw, I'd only need to get the x cubed and the x squared part from this 3 minus 2x, right? So I can save myself a lot of hassle by only finding those 2 terms rather than finding the full expansion. Anyway, so then that's what I'm going to do. So 3 minus 2x to the 7, okay. Well, firstly the x squared term, that's going to be, well, 7 choose 2, then x squared, then the other, but it won't be x, will it? It'll be minus 2x, right? To the power of 2. Then 3 would then be a power 5. If we put all that in a calculator, well, 7 choose 2 is 21, times by minus 2 squared, that would be 84, then times by 3 to the 5, it'd be 20,412 x squared. Then the x cubed term as well, because we'll be needing that. But then that'd be 7 choose 3, then minus 2x to the power 3, then 3 would then be a power 4. If I put all that in the calculator, well, 7 choose 3 is 35, times by minus 2 to the power 3 is minus 280, times by 3 to the 4. So then I would get minus 22,680 x cubed. So there we are then. So that's the terms that I'm interested in for this expansion. But then, so what we're going to have then is 2 plus x, then 2412 x squared minus 22680 x cubed. Okay, so that's what I've got. So as we discussed then, so this is the actual kind of bracket now, because I found the missing coefficients. Okay, well, how am I going to get x cubed from here then? As we discussed, the 2, the first term in the left bracket, that has to be multiplied by every term. Now, how are we going to get x cubed? Well, it's going to multiply by the x cubed term here. So therefore, the x cubed term overall is going to be 2 times minus 22680 x cubed. Then the x also has to be here, then has to be multiplied by every term as well. Which of those multiplications is going to give me x cubed? Well, it's going to be the x squared, right? Because x times x squared is x cubed. So that would be x times 20412 x squared. And so there we are then. If we then just simplify this, 2 times minus 22680 is minus 45360 x cubed. Then this, well, x times that x squared, that's just 20412 x cubed. So there we are then. So we just add them together. We then get overall we get minus 24948 x cubed. There we are then. So that's the x cubed term overall for that double bracket there. So the coefficient then, the number in front, is simply minus 24948. There we are. Cool. So yeah, that can be a bit tricky to visualize and do it at the first for the first time. But hopefully, as we go through the examples, you can start to spot how I can save my work in. We're not doing the full expansion, but then picking certain terms that I need, and see how things expand. A lot in the way we did here. But yeah, okay. Let's have a look at this example. G of x is 1 plus kx to the power of 10. Given that the coefficient of x cubed in the expansion is 15, from the value of k. Right, so they've told us a particular term. So they said the x cubed term, well, the coefficient of it is 15, so it's 15x cubed. Well, that's telling us to find this unknown k, we need to consider the x cubed term, okay? So even though there's a number k, there's a bit of algebra, we do the normal way. So we expand it in the normal way, but we want the x cubed term, right? We don't want all the other terms because it's not going to help us. So x cubed, well, firstly that'd be 10, then choose 3, then the power of x is cubed, so we're going to have not x cubed, but kx cubed. Then we're going to have that 1, the other number, then to power 7, okay? So we can simplify this a little bit because 10 choose 3 firstly is 120. Then k, well, that'd be kx all cubed, well, that's just k cubed times x cubed, right? We can split that bracket up using index laws, so there we are. Then 1 to the 7 is just 1, so that's just itself. But then overall then we get 120 k cubed x cubed. Well, there we are then, the coefficient in front has to equal the coefficient we're given, so therefore 15 is equal to 120 k cubed. Well, then we can easily solve this for k then, can't we? Because then k cubed is then 15 over 120, which is, does it simplify? It does. K cubed is an eighth. There we are. Well, then to get k, we can just cube root it, right? And so if I do that, put that in the calculator, that's going to get me a half. And there we are. Cool. And also to emphasize, to remind, you only get one value. There's no plus or minus because it's an odd root. Alright. Be cube rooting, you do not do plus or minus because say -1 cubed, but that's -1 3 times. That would still be -1. So there's no minus case to consider as well. Just to remind on that, okay? Only when you're squaring or to the power 4 or anything like that. But for cube rooting, no plus or minus. Anyway, so that's my answer. Cool. So hopefully, again, you can see the power, especially in exam situations to save time. By not doing the full expansion, only pick out certain terms that we need in this case. Okay, cool. This example then says write down the first 3 terms in ascending powers of x of the binomial expansion of 1 plus qx to the power of 8. Okay, so again, it's pretty much what we did last time. In the last section, we just need to find the first 3 terms of x. So obviously, again, it's a q, but we just do the norm. We just do it as exactly as we normally do it with actual numbers. Anyway, so the first term is going to be 8 choose 0. Then that's going to be qx all to the power of 0 because we've got qx, not x, remember. And then the other number 1 here, that'd be 1 to the power of 8. Then we're going to have 8 choose 1 for the next term. Then that'd be qx to the power of 1. The 1 would then be the power 7. Then we'd have 8 choose 2, and then qx would all then be a power 2, and then 1 would then be a power 6. And there we are then, so those are the first 3 terms, right? So then we just need to simplify, put it in the calculator. Well, 8 choose 0 is 1, qx to the power 0 is just 1 as well, and we get 1, so the first term's just 1, right? Overall, this first term's 1. Then we're going to have 8 choose 1, which is 8, then qx is just qx, right? So we're going to have 8qx, and then 1 to the 7 is 1 as well. So overall 8qx for that term. Then this one, well, 8 choose 2 is 28. Then 28 times qx all squared, that's 28 q squared x squared. And then 1 to the 6 is just 1 again. So there we are then. So those are the first 3 terms in terms of q. Cool. Then part B, given that in the expansion of 1 plus qx to the 8, which is the same bracket, right, that we did in part A. In this expansion we find with the coefficient of x is minus r, and the coefficient of x squared is 7r. Find the values of q and r. So, they told us now, very kind of similar to the last example, but the x term, firstly, is the coefficient's minus r for some r, right? Number r. So it's minus rx. and the x squared term is 7r, so it's going to be 7rx squared, right? Well then, if we compare our expansion, well, the x term is 8qx, right? So that means 8qx has to equal rx, right? Or minus rx, sorry. But then, well, the coefficients are the same, so therefore 8q is equal to minus r, okay? Can't do anything more with that, but I can get another equation now by using this, the x squared part. Well, again, the x squared part we found in part A was this, 28q squared x squared. But the x squared part we're given is 7r x squared. So that means 28q squared x squared has to equal 7r x squared because they're the same. Then again, if we compare the coefficients then, 28q squared has to equal 7r. And so actually then I've got simultaneous equations, right? So it's just a simultaneous equations question now, effectively. So how we can solve it? Well, substitution, right? Because if we then multiply this by if we switch the negatives, right, times by minus 1, we'll get r is equal to minus 8q. But there we are then. So then if I sub this expression r into the second equation, right? What I'm going to get then is 28q squared is equal to 7r. So that's 7 lots of minus 8q. Well, there we are then. I can expand this. So 28q squared is 7 times minus 8, which is minus 56q. So if I add that to the other side, 28q squared add 56q is equal to 0. And there we are. And so then I can solve this by factorising. Well, q obviously I can pull out, but also 28 goes into both terms as well. So 28q, then 1, well no, that'd be q plus 2 is equal to 0. 56 divided by 28 is actually 2. So there we are then. We can factorise pulling out the terms that are in both, the factors that are in both terms, there we are. Okay, but then I need to set each each factor equal to 0 to solve it. So that means either 28q equals 0, which obviously means q equals 0, or q plus 2 equals 0, which means q is minus 2 if I solve that. There we are then. So we've got two solutions, 0 or minus 2. Well, which one do we accept? Because there's two of them. So we need to read the question in this case to if it's given any condition, any information about q. Yes, here. The told us q is a non-zero constant, so it's non-zero. Well, hence q cannot simply be 0, right? Q is non-zero. So therefore, we can't have that one, so we can only take q as minus 2. There we are then. But we then need to find the value of r, right? But we can find that right quite easily because we said r was minus 8q here. So r is minus 8q. Therefore r then, if q is minus 2, that's minus 8 lots of minus 2, which is plus 16. There we are then. So we've got the values of r and q. Cool. Okay. There we are. So hopefully you start to pick up a gist of these type of questions now. If you give information about the coefficients, you can equate stuff together. You can find a particular term again by considering the coefficient and the terms. But there we are. Okay, let's have a look at some exercises, some more questions. Okay, so got this challenge question first, but weirdly, I don't think it's the hardest question in that exercise. So I'll do it first. So we're given f of x is 2 minus px, 3 plus x to the power 5. We are given there is no x squared term in this expansion of f of x. Show that p is 4 over 3. Okay. So we're told information about x squared. Now, they said there's no, badly underlined, there's no x squared term. I picked this question for this exact reason. Because if you're a bit thrown off by it, well, we can address it now. So no x squared term, that means, well, the x squared term is 0, right? So that means the x squared term is just 0 x squared. Obviously they're not going to go to 0, so there's no x squared term. That's what that means. So there we are then. So we need to consider the x squared term again here. How am I going to get x squared again? We've got a double bracket situation, like the first example. How am I going to deal with that? Well, I have one sort of normal bracket, right? It's not raised to the power. I can't do anything more to expand it. This I can. 3 plus x to the power 5, I can expand that by the binomial theorem. But I need to be a bit selective to save time and to cut down on working. Because I can only... I only need to consider certain certain terms of x, right? Now think about it. I have 2 minus px, right? And this will also give me a some sort of polynomial, right? So we're going to have 2 minus px. Then it's going to look like some polynomial. X to the 0, x to the 1, x squared, and then x to the 5, right? Last, right? So how, again, firstly, this... I need to multiply all the terms in this first bracket. So firstly the 2 by every term in this bracket again. So 2 times x is 0, 2 times x squared, so on. Which of these multiplications is going to give me x squared? Well, it's just going to be 2 times x squared, right? In that way. Then the next term, minus px. Well, again, that's effectively just x, right? Minus px then. Again, I'm going to have to times that, because of how we expand brackets, by every term in this bracket, right? Again, how am I going to get x squared by that? So then it's going to be minus px times x, right? Because then minus px times x, well, x times x is x squared, so there we are then. Ignore the coefficient, that gets me the x squared part there. So therefore then, that tells me I only need to consider the x term and the x squared term of this bracket, okay? So I don't need to find all the terms in that expansion, only the x and the x squared term, right? Which allows me to find the overall x squared term in this way. Okay, cool. So that's what I'm going to do. So I need the x and the x squared term. So for 3 plus x to the 5 alone, well, firstly the x term, that's going to be then 5 choose 1, because then that's x to the 1 effectively. But then the power, the term of x will be x to the 1. Then we're going to times by 3 to the power 4. Obviously then the powers match to 5 overall. There we are then. We put that in the calculator. Well, 5 choose 1 is 5. But that's just 5. Then we have 5 times 3 to the 4. That's going to be 405 x. And there we are, okay. Then we have the x squared term as well. That's going to then be 5 choose 2 x squared, and then times 3 to the power 3. Okay, put that in the calculator. Well, 5 choose 2 is 10 times by 3 cubed. I get 270 x squared, and there we are then. So therefore, then in our expansion, we have we can say 2 minus px. Then the terms we want is 405x, add 270x cubed. Well, therefore then, in the expansion, if we want x squared, remember, because we got the x squared term, how are we going to get x squared in this expansion? Well, firstly, the 2 has to multiply by the x squared part, right? So that's be 2 lots of 270x squared. And then we have minus px, then times by what? The 405x, right? Because then x times x is x squared. So 405x times minus px will get me the x squared. So if I just put this in the calculator then, to simplify it, well, 2 times 270 is 540 x squared. Then we have minus px. Times 405x, that's going to be minus 405p x squared. There we are then. So that's the overall x squared term. But we are told there's no x squared term. right? That means the coefficient 0. That means then that 540x squared minus 405p has to equal 0 to give the overall coefficient of 0, x squared, right? So we equate the coefficients, and then we just solve for p. 405p is 540, therefore p is 540 divided by 405, which gets me 4 over 3. Well, there we are then. It show that p is 4 over 3. There we are. Cool. So there we are then. Okay. So let's have a look at this question then. We are told when 1 minus 2x to p, so there's an unknown power here, the coefficient of x squared is 40. That's telling you then the x squared term is going to be 40x squared, right? Coefficient of 40. Given that p is greater than 0, use this information to firstly find the value of p. Okay, so even though there's a p, there's an unknown, right, unknown term, we can still proceed in the normal way, right? So we are told information about the x squared term, so we should consider the x squared term, right? So 1 minus 2x to the p, the x squared term of this is going to be, n is going to be p, right? So it's going to be p choose 2 times then by minus 2x, so not x, but minus 2x, that's what we've got here, all to the power of 2. Then the 1 is then a power of, if we want, we need to add up to p, so it's going to be p minus 2, right? But it doesn't matter, because 1 to the power of anything is just 1. But there we are. Now we can simplify this a little bit. We can't evaluate this coefficient because it's an unknown. We can't put it in the calculator because there's an unknown value. So we can't do anything with that. But minus 2x all squared, that is going to be 4x squared, right? And then 1 to the power of n, which is 1. So there we are. So this is simply p choose 2 times 4x squared. Okay. Now I need to evaluate this, right? This coefficient. Now what you need to remember is we can write a general coefficient n choose r in terms of factorials in this definition. So it's n factorial over r factorial, n minus r factorial. Now remember that is in the formula book. However, you still need to know you need to be aware it exists and be aware how to use it, right? But this is the formula, so we can kind of substitute this in and say, well, p is n, so it's p factorial, r is 2, so that's 2 factorial, times n minus r, so it's p minus 2 factorial, okay? And that's still times by 4x squared. Now actually we can simplify this because 2 factorial is 2 times 1, right? Remember when we looked at factorials? So that's simply p factorial there then over 2 times p minus 2 factorial. But then we times in by 4x squared. Now the 4 and the 2 here will cancel, right? So you're going to be left with p factorial over p minus 2 factorial times 2x squared, right? And so there we are. I can't do anything more with that. Now, remember we are told the x squared term is 40x squared, right? So this means if this is the x squared term, that has to equal 40x squared, right? Well, then we can compare the coefficients then, right? So the numbers in front of the x squared to then say, well, p factorial over p minus 2 factorial times 2 is equal to 40, right? If we compare the coefficients. Okay, then we can start to solve this for p. Well, first of all, I can divide both sides by 2. to get p factorial over p minus 2 factorial is equal to 20. Okay, right, okay, so how do we solve from here then? There are two ways I can spot. You can do it algebraically, which I'll show in a minute, but I think because it's such a small number, I think we can try a few values of p, right? And then see when this equals 20. So we could try firstly p is 1. No, but the problem is if p is 1, then p minus 2 factorial will be minus 1 factorial, because 1 minus 2 is minus 1. Now that doesn't exist. Uh, well, technically it does, but you won't need to work with negative numbers with factorials. It goes from 0 factorial upwards, okay? So it can't be p is 1. That's not what we're going to try. So then p is 2 is next. So we can try substitute p is 2 in to see if the formula equals 20. We have 2 factorial then over p minus 2 is 0 factorial. Now 2 factorial is 2 times 1, which is 2, sorry. And then 0 factorial is actually 1. We did look at that when we looked at factorials as well. We saw that 0 factorial goes to 1, which is important. So that does exist. We're not dividing by 0. 0 factorial is 1. So that goes to 2. Well, that isn't 20, so let's try another value. Let's try p is 3. Well, then we're going to get 3 factorial over 3 minus 2 is 1 factorial. Well, 3 factorial is 3 times 2 times 1, which is 6. 1 factorial is just 1, so we get 6. So not 20, let's try another value. If p is 4, then we're going to get 4 factorial over p minus 2 is 4 minus 2, which is 2 factorial. Now 4 factorial is 4 times 3 times 2 times 1, which is 24, and 2 factorial is 2 times 1, which is 2. That gets me 12. So I'm getting warmer to 20, but not quite. Let's try another value. P is 5. So then that'd be 5 factorial over 3 factorial. Which then 5 factorial is... and also remember, you can work out factorials directly in your calculator. The calculator does have a factorial button, which we looked at in the factorial video. But anyway, 5 factorial is 120. 3 factorial is 12. Is it? No. No, it's 6, sorry. 6. Well, 120 over 6 is 20. Well, there we are then. We got 20, so that means p equals 5. Cool. So that's probably the best way to approach it. Well, probably the easiest way, I guess. The simple way. The other way, I've said algebraically, you don't have to try values of p, although they were quite small, so you didn't have to try for many values. But you could have said, well, p factorial is actually, well, as we said, it's p times p minus 1 times p minus 2 all the way down to 1, right? So all the numbers before it get multiplied together. Well, actually, p minus 2, and then we times by all the numbers before it, isn't that the rest of it just p minus 2 factorial? We could just say that, right? And then we're dividing this again by p minus 2 factorial, right? Down here, right? So this is p factorial. So this is that fraction. I've just used the factorial definition, right? That's a very common idea when you're dealing with this sort of a factorial fraction. You might want to so-called expand it, expand the factorial, right, by considering the multiplications. But what you can see here is then these p minus 2 factorial is common, so I can cancel that out. So simply I'm left with p, lots of p minus 1, and then that has to equal 20. Well, from there, this is a quadratic, right? You'd get, if you were to expand this, you'd get the quadratic p squared minus p minus 20 equals 0. Then you would solve it, right? You'd get two values. One of them would then be p's 5. However, the other one I think might be negative because it says p is greater than 0, so that means you only accept the positive solution. So you'd get p's 5 if you solved it that way. That's the more algebraic way, I guess the proper way, by considering by expanding the factorial and cancelling out any multiplications. But I guess probably the just trying a few values of p is probably maybe the better way of doing it for most people. But there are two ways of approaching it. But anyway, but yeah, they don't ask questions like that very often when you need to consider the factorial definition, with the fractions and stuff like that. But be aware of it, right? Hopefully you understand what I did there. Be aware of how we can solve it using that formula. But yeah, okay. Let's have a look at and then part B. Now that we know what p is, it's asking us to find the coefficient of x and x cubed. Well, that's fairly standard because now what we have is 1 minus 2x to the p. Well, that's going to be to the 5, right? So therefore, the x term of this expansion is going to be, well, 5 now. Choose 1. And then we're going to have minus 2x to the power of 1. And then the 1 here is then going to be a power of 4. And so if we evaluate that, well, 5 choose 1 is 5. 5 times minus 2 is minus 10. And then times by 1 to the 4, well, that's just 1. So it's just minus 10x. There we are. And then it says to find the x cubed term. Well, that's going to then be 5 choose 3. And then minus 2x will then be a power of 3. And then 1 will then be a power of 2. So if we evaluate that, well, 5 choose 3 is 10. And times by that by minus 2 cubed, that gets me minus 80. So that'd be minus 80x cubed. As 1, obviously, 1 squared is 1. So there we are. Cool. Yeah, so I guess I'll just say, I've not seen an exam question. Part A can be quite tricky, right? But I've not seen an exam question like Part A where you need to use this factorial definition, which, to remind you, is in the formula book. But again, be aware of examples of how we can use it, right? So hopefully you kind of understood what we did there. But yeah. So have a look at another example. This one then says, find the constant term of the expansion of x squared over 2 minus 2 over x. And that'd be a power of 9. Right, so the constant term. Now, it would not be as simple as saying, well, the constant term is basically x to the 0, right? Because obviously x to the 0 goes to 1, so there's no x, right? So you want a constant term being a term with no x in. Now, you might think, well, let's just do 9 choose 0, because then, let's say this x squared, right? X squared over 2 would then be a power of 0. But then we would have minus 2 over x, which would then have to be a power of 9. The problem is, well, 9 choose 0 is 1, x squared over 2 is 1, because it's power 0. That would then be minus 2, minus 2 to the power of 9, which would be minus 512 over x to the 9. That has an x in, so it's not the first term, unfortunately, because that has an x in. Now, it's very tricky to spot then what term then would actually give us a constant where the x's go away. Because we've got a problem, because we've got an x on the numerator here, but then we've got an x on the denominator there. So it's a bit more complicated because therefore the x's will cancel when we multiply them together. So it's not as straightforward to find the terms where we will get the constant term. What we could do in that case is, if we don't know what particular term like this will give us the term we want, which is a constant, We can then just try first few terms and see what happens. So then the next term would be 9 choose 1. Okay, so going up by 1. Then x squared over 2 would then be a power of 1. Then minus 2 over x would then be a power of 8. Then 9 choose 1 is 9. X squared over 2, so that's a half. So then 9 times a half. Then we're going to get minus 2 to the power of 8. So 9 over 2 then times by minus 2 to the power of 8 is 1152. Then we're going to get x squared from this bracket, but then we're going to divide it by x over 8 from that third bracket there. Okay, so I've got the constant term, okay, but then the x's are dividing, right? I should say as well, emphasise, the constant 1152 came from 9 choose 1, which was 9. Then x squared, well, we got a half, right? X squared over 2. So then we times that by a half. Then we pulled out minus 2 to the 8, right? And that gives me 1152. Okay, that's how I'm working out my constant there. Just to break it down clearly. Because by the way, it's like minus 2 to the 8, x to the 8 as well. If you remember the index laws, we can split that up to minus 2 to the 8 over x to the 8. That's all I've done here. Okay, I just wanted to clarify that. How I'm working out these numbers. Okay. So, but anyway, back to this. Overall, we get this. X squared over x to the 8 is just 1 over x to the 6, right? So that's 1152 over x to the 6. So I'm still got an x term. I'm dividing by x, right? But I'm actually getting a bit closer because I'm starting from x to the 9 and I've got x to the 6. Let's try the next term and see what happens. Then the next term is 9 choose 2, x squared over 2 squared. Then minus 2 over x will be a power of 7. If we work that out, well, 9 choose 2 firstly is 36. Then we times them by a half squared, which will then get me 9. Then times by minus 2 to the 7. Overall get minus 1152. Then x squared squared here. X squared squared is x to the 4. But then we're dividing by x to the 7 from there. So overall that goes to minus 1152 over x cubed. Well, actually then hopefully you start to notice the pattern. We have x with something over x to the 9, then we have x over x to the 6, and now we divide by x cubed. The numbers are going down by 3 each time, right? Well, you'd think next time then we would have some number, so it'd be like 1 over x to the 0, right? Because we're going down in 3s and powers of x. Well, x to the 0 will just go to 1, so that get rid of the x. But let's just work out the next term then, right? So 9 choose 3, then x squared over 2, cubed, minus 2 over x power 6. If we work that out, well, 9 choose 3 is 84, times by a half cubed is at 10.5, then times by minus 2 to the power 6, we get a positive 672. Well, x squared, which is then cubed, that's x 2 times 3, which is 6. Right, remember your power laws? So that's x to the 6, and then we're divided by x to the 6 as well, right, from there. And there we are then. Well, the x to the 6 is cancelled, so I'm just left with 672. So that's my constant term. Cool. So therefore then, constant is 672. Cool, so hopefully you see what I did there. That was a bit of a tricky example as well, but hopefully you saw what I did there. Well, I couldn't spot right away how I could get the constant term, because obviously the first term didn't give me a constant, a term with no x in. So what I did then is just tried the first few terms then in the expansion, and then I noticed a pattern where the x's go down by 3 each time, and eventually I got my constant by trying the first few values, and that is my tip. If you're struggling to deduce a certain term, do the first few terms of the expansion and see what happens. There we are. Okay, and we've got this exam question then. So find in simplest form the coefficient of x to the 5 in the expansion of 5 plus 8x squared, and then 3 minus a half x to the power 6. Okay, so it's vaguely familiar with one of the other examples we looked at. So again, we only need the x to the 5 term, right? That's all we need. We don't need the full expansion. Now think about it, we got another double bracket then, but the first bracket we can't expand anymore, simplify, it's just 5 plus 8x squared. But this other bracket is to the power 6, so I can sort of expand that. But I don't need to expand the whole thing, or else I'll be wasting time. Think about it then, if I was to expand this, I'd get a polynomial, right? Powers of x. Now think about it then, 5 times what? Well, firstly, with how we expand brackets again, the first term, the 5 in the first bracket, has to multiply by every term in the other bracket. Think about it then. What am I multiplying 5 by to get some lots of x to the 5? How am I going to get a power of x to the 5 here if I multiply by 5, which is a constant? Well, 5 times something is x to the 5. Well, we're going to have to multiply by an x to the 5, right? So that means then, firstly, from my expansion of this bracket, right, the right bracket, I need an x to the 5. I need to find the x to the 5 term to multiply by the 5 here to get the x to the 5 term overall. Okay, so x to the 5. Well, that's from this bracket. That's going to be 6 choose 5. Then the x part minus the half x would then be a power 5. Then the 3 would then be a power 1. Put all that in the calculator. Well, 6 choose 5 is, which is 6. And then 6 times the minus a half here to the 5 is minus 3 over 16, and then times by the 3. We get minus 9 over 16 x to the 5. Okay, so that's the 5 then. That's how we can multiply with this expansion to get an x to the 5. Then what about the x squared part here? Then this also has to multiply by every term in this expansion. Now think about it, every term is going to be a power of x. So what power of x am I going to multiply x squared by to get x to the 5? X cubed, right? X cubed times x squared would then give me x to the 5. So that's telling me I need to multiply by x cubed, so I need the x cubed term as well. Okay? From this expansion. So that's be 6 choose 3. Then minus a half x would then be a power of 3. Then 3 would then be a power of 3 as well. Those are 3's. If I put that in the calculator then, well, 6 choose 3 is 20 times by minus a half to the power of 3. That's minus 2.5 times by 3 cubed. I get minus 135 over 2x cubed. Yes, x cubed. But there we are then. So those are the two terms I actually need from the expansion. Okay. So then, therefore, then the overall x to the 5 term from this double expansion, which is what we needed. Right. So firstly, this 5 then is again going to multiply by the x cubed x to the 5 term here to get me x to the 5. So 5 lots of minus 9 over 16 x to the 5. Add then the 8x squared then. That part is then going to multiply by the x cubed part to get me x to the 5 as well. So overall then, if I add these together, I get the term is 5 lots of minus 9 over 16 x to the 5. Add 8 times minus 135 over 2 x to the 5. I get overall that is minus 8685 over 16 x to the 5. And therefore, that's my overall x to the 5 term. So therefore the coefficient then is minus 8685 over 16. Cool, so again, hopefully you understood what we did there. We didn't consider the whole expansion of this, because I only needed actually only certain terms in the expansion, namely the x to the 5 and x cubed term, because the 5, again, firstly, the 5 multiplies by every term in the expansion. Well, how am I going to multiply? What am I going to multiply 5 by to get x to the 5? Well, x to the 5, right? The x to the 5 term. Then the 8x squared part here would then also multiply by every term in the expansion of this bracket. But again, x squared then times x cubed will get me x to the 5. So I only needed the x cubed term to get x to the 5 overall. And so I just added them two together at the end. Okay, cool. Final question. First of all, for part A, it wants me to find the first 4 terms in ascending powers of x for the expansion 3 minus 2x over 9 to the 8. Now actually I'm going to rewrite this a bit more clearer, I guess, just very, very slightly. I can say this is 3 minus 2 over 9 x over 8, okay? Because then hopefully you see that it is a coefficient, okay? It makes it a bit more clearer when I do my terms. But it's asking me for the first 4 terms, okay? So first 4 terms of this expansion. So that's going to be then 9, firstly 8 choose 0. Then minus 2 over 9, x would then be a power of 0. And then the corresponding 3 would then be a power of 8. The next term then would be 8 choose 1, minus 2 over 9, x to the power of 1 then. And then 3 would then be a power of 7. The next term then would be 8 choose 2. Then minus 2 ninths, x will be a power of 2. Then 3 would then be a power of 6. Then the next term would be 8 choose 3. And then minus 2 over 9x will be a power of 3. Then the 3 would then be a power of 5. Now actually, those are the first 4 terms then. But then we can say, we can add this dot dot dot, by the way, to mean, obviously there's more terms next, right? But I'm just cutting it off at the 4th term because that's what they asked me to do. But in reality, there will be more terms, but we don't need to consider that, which is what the dot 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 means. But anyway, these are the first 4 terms then. So just then evaluate this in the calculator, right? So 8 choose 0 is 1, minus 2 ninths x to the power of 0 is 1 as well. So just 3 to the 8 is 6, 5, 6, 1. Then we have this next term here. 8 choose 1 is 8. 8 times minus 2 ninths is minus 16 over 9. Times by 3 to the 7 is minus 3888x. Okay, then the next term is 8 choose 2, which is 28. Times by minus 2 ninths to the power of 2 would then be a fraction. Then times that by 3 to the 6, I get that is 1008 x squared. And then this last part here, 8 choose 3 times minus 2 ninths cubed is a fraction again. I'm not going to say it, but it's a fraction. Times by 3 to the 5. And we get minus 448 over 3 x cubed overall. And then we can also add this dot 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 if we wanted to, but to signify there are more terms in the expansion, but we only want the first 4. But there we are. So that's part A then. Those are just first 4 terms. And also to say, it says in ascending powers of x, but don't need to worry about that because all that means is the x powers increase as you write it, right? Which is what we can see here, because we have a constant, and an x term, then an x squared term, then an x cubed, and it would go on. The way we do this binomial expansion always is in ascending powers of x, so no need to worry about that, but that's what that means. Anyway, part B then, the next part of the question, the harder part, we are then given this f of x, which is x minus 1 over 2x, I think. Yes, and then the 3 minus 2x, 3 minus 2 ninths x to the power of 8, which is what we did in part A, Yep. Okay, so now we've got a double bracket, and it's asking for the coefficient of the x squared term, right? So we need to only consider the x squared term of this double bracket. Okay, so it can be tricky then to see exactly how we could get an x squared term out of this double bracket, right? Because this is a bit of a weird fraction here in this first bracket. Because we've got x on top and the bottom, right? But actually, we can simplify this if we just split up the fraction, right? Because then we say x over 2x minus 1 over 2x, and then times by 3 minus 2 ninths x to the power of 8, which then goes to, well, x over x goes cancelled, so we get a half, take away 1 over 2x, then to the same bracket, 3 minus 2 ninths x to the 8. So it resembles pretty much the brackets we've been working with in the other examples, right? We can work with this now. It's a bit clearer to see what we need to do. Okay, so again, we need an x squared term from this, right? From this double bracket. How am I going to get x squared? Well, again, firstly, the half is going to first multiply by all the terms in this expansion in the right? Now think about it, this expansion will be powers of x. So a half then, which is a constant, times by what power of x gets me x squared. Well, that's going to be the x squared, right? A half times x squared gets me the x squared term. That means then I need the x squared term from this expansion first. So I'm going to say 3 minus 2 ninths x to the 8. The x squared term. Okay. The x squared term then, I'll do it down here. From this bracket, this expansion. So actually, to find the x squared term then for this expansion, I don't actually need to compute it because I've already done it in part A. I've already got the first 4 terms of that expansion in part A. If I need the x squared term, well, it's just this, right? The 1008x squared. So I don't need to do any work with that. I've already got it. 1008x squared. So that's with the polynomial. That's half then dealt with. But then now this minus a half x. Minus 1 over 2x, right? That still has to multiply by every term in that expansion, which again will be a polynomial with different powers of x, right? Now again, which power of x then would multiply by 1 over 2x minus 1 over 2x, right? Times by power of n. I need to get x squared out of it, right? Lots of x squared. How am I going to get x squared for multiplying something like 1 over x, right? Well, hopefully you realise it'd be a cubed term, because then x cubed over x will cancel to get x squared. So I need the x cubed term from this expansion, right? Because that x cubed term is going to multiply by 1 over 2x, and that'll cancel out to get me an x squared term, which is what I need. Alright. Well, again, the x cubed term, I don't need to work it out explicitly, because I've already done it in part A. It's this term, right? Minus 448 over 3x cubed. That's the x cubed term from that expansion. Yes. So therefore I can basically just copy and paste, right? Because then the overall x squared term from this double expansion. So these are the single. That's the single bracket, right? That's the expansion of the single bracket. Overall double bracket, then the x squared term. The half would have to multiply by the x squared term to get an x squared. So a half lots of 1008x squared, and also then the minus 1 over 2x. Then have to multiply by the x cubed term there to cancel down to x squared. So minus 448 over 3x cubed. If I then just evaluate all that, put that in the calculator, well, half of 1008, 504, and then minus 1 over 2, actually, yes, well, the first bit is 504 x squared. Then we get minus 1 over 2x times minus 448 over 3x cubed. And the minuses are cancelled to get plus 448 x cubed over 2x times 3 would be 6x if I times the bottom and the top fractions, right? Times the two fractions, you times the top and the bottom. So then I can simplify this. So I can, well, the x cubed then would then over x, that would cancel out to get x squared, right? There we are. So we've got an x squared term. Cool. So then I just need to add them together to get the overall term, right? So 504 add up 448 over 6 gets me the fraction 1736 over 3x squared. And there we are then. So therefore the coefficient of the x squared term is 1736 over 3. Cool. So yeah, so those are the examples. But hopefully you understand how we deal with these questions now. Instead of expanding it all and wasting time, you can expand it all if you're really, really struggling to see how to pick out a certain term. Maybe with a tricky bracket, expand the term if you want. It might take a bit of time, but you can do that. But you can save time if you can spot how things expand. And so what terms you need to select from an expansion. Because oftentimes they're only asked for one particular term. So you can cut time by doing that, and hopefully you've seen with these examples how you can sort of pick out the terms we need by considering how things multiply and expand together. But yeah, so that's looking at some more trickier problems with binomials. So I'll see you next time.